The last idea for section 3.1 is called the difference quotient. I'm going to be honest, I actually dislike the place the book puts this because we're actually going to do some math in 3.3 that gives you some inside groundwork on what the heck this is. But I think it kind of getting in what the book's trying to do, maybe they're just worried about the mechanics of it, and then understanding what it is will come later. So what I want to point out to you is h is usually some number. Okay, so it's not a function, it's some input value, it's some number. Of course, x, right, that's basically our input variable. I don't know if I'm even pronouncing that. So h is some given number, x is basically our input variable like it's always been, and of course f is our function name. So that kind of hopefully explains a little bit of what you're seeing here. So again, we're taking, there's a difference here, hence the name difference quotient, right? Because we're taking that difference and we're dividing it by h. F of x is basically the function, right, called f that depends on x. We're taking that function and we're putting in x plus whatever that number is. So x plus 2, x plus 3, heck, even minus, right? X minus 1. So remember, h is some number that we can add or subtract our input variable for. And then putting this all together, right, we create the difference quotient. So the mechanics look like this. Let's give ourselves a function. So if my function is 3x plus 5, all right, the first thing I have to do is I got to figure out, because one of the major components to our quotient is the value of x, f of x plus h. So this is being replaced there. So we have 3x plus h plus 5. Cleaning this up, that becomes this. So here is f of x plus h. Here was the given function. So we're ready to go to the difference quotient. So let me rewrite it. So the difference quotient will basically be, right, this piece we found here. So that's 3x plus 3h plus 5. And we're subtracting whatever f of x is, right? So f of x is 3x plus 5. And we're all dividing it by h. So we found f of x plus h for the given function. We put it here. We're subtracting, right? Hence the name difference, whatever f of x is. That's the given function. Taking that result and dividing it by h. So now it's just a bunch of cleaning up work. Upstairs, if we drop those parentheses and distribute that negative, we have that. We do see a cancelization, right? 3x minus 3x and 5 minus 5. So we're basically left with 3h over h. Of course, those h's are common, so we're left with 3. So for this function, right, for the function 3x plus 5, the difference quotient is equal to 3. And there's the mechanics. Obviously, I'll do a couple more so you can kind of get used to this. But inside information, this is just a fancy way of writing slope. And to show you that, if you go back a few sections, I think section 2.2, we learned about lines, right? This is your mx plus b. So the slope is equal to 3. And notice that the difference quotient, right, is also equal to 3. So that's what this basically is. It's a very, very, very fancy way of writing the slope, right, for a function. But more on that later in terms of details, but there's some inside information. Let's just worry about the mechanics again. So this time, I've got a new function, right? Let me stay with f of x. And our new function is called x squared minus 3. Okay, so there's the function. So I already know what f of x is. To use the difference quotient, I need to know what f of x plus h is. So for this function, this would be x plus h squared minus 3. This is x plus h times x plus h minus 3. If I FOIL this out, and combine like terms, there is f of x plus h. Okay, so for the given function, I replaced the input with x plus h, did some math, and there's the expression representing f of x plus h. So we're ready for the difference quotient, right? So let me rewrite it. So the difference quotient is the function at evaluated x plus h minus the function evaluated at x, all divided by that number h. So if we fill in all the details, right, this part is x squared plus 2xh plus h squared minus 3, and we're going to subtract the function x squared minus 3, and that's all over h. So f of x plus h minus f of x. So I'm just replacing what these two guys are. F of x was given, f of x plus h we had to find by inputting the x plus h. And then we clean it up. If we clean up the upstairs, we can begin that journey by distributing that minus sign. When we do that, the x squareds will go away, the 3's will go away, and we have 2xh plus h squared all over h. Of course, there's two fractions here, or you can think of it as this is h times 2x plus h all over h, right? I just factored the h. There's a common h upstairs, so I factored that GCF out. That h divides out with that h, and there is the difference quotient. So for this quadratic function, x squared minus 3, its difference quotient is 2x plus h following the math. All right, so obviously I got to do some more practice of this. I'll do that in another video coming up shortly.